Hello guys, in this video we are going to talk about DOP networks and the difference between them and SOPs. And we are going to create data in DOPs and learn how to modify them. So DOP networks or dynamic operators, they are called dynamic because they work with simulations in Houdini. Actually, they are called dynamic because you have you have the data and you solve these data or modify them on a specific frame, then you transfer these data to the next frame. So for example, when you are in frame 5, for example, you solve or modify the data using the DOP nodes, the gas microsolvers, and the different nodes, or the solvers, or the present solvers, or the default or preset solvers in Houdini, like the smoke solver or the pyro solver. You modify the data. For example, in this frame, let's talk about frame 2. You modify these data and then transfer them to frame 3, where they get modified and operations are done. Then they are transferred to frame 4 and so on and so far. So this is what is happening in what happens in DOP networks. Okay, in contrary, in SOP networks, you solve or you do the operation once for all. So when you extrude a sphere, for example, or move it, you move it once for all. Even in moving objects, when you keyframe something, or when you, for example, uh, mesh a particle fluid where the particles move each frame, you are just doing this each frame independently of the previous frames. You are not accumulating data here. You are just solving or doing the operations in a specific frame, maybe frame 1, frame 2, frame 3, whatever you are doing. But this is not like DOP networks where you do the simulation cumulatively. You solve the data from the previous frames. And actually you can even divide the duration between two frames into substeps, where you solve the data in the first substep and transfer it to the next substep, and so far and so on. So this is what happens in the DOP networks, and this is why they are used for simulations. So let's dive into this DOP network here. And here in this DOP network, if we go to the spreadsheet here, we can see everything here about the data that we are going to create. So to create a DOP simulation, firstly, we need an object which is the container of the data. So to create an object, for example, that is empty, we have here this node called empty object. But don't forget that here we have a smoke object that is made in Houdini, and we have a flip object, and we have a lot of you know made objects in Houdini that are assigned with different data. We are going to talk about this, but let's talk firstly about this empty object here. Here we have this object name. We can call it a smoke object, as we are going to build a simple smoke solver here. So if we rename this to smoke obj, here in the geometry spreadsheet we have this smoke obj, okay, which we can open here to see the different data we are going to store in this smoke object. So this is our container here. Here we are going to assign our data. And as we talked about in the last video, data in DOPs are usually represented as fields or volumes. So when we have a smoke solver, we are going to create fields for different data, for the density, for the temperature, for the divergence, for the different type of data, for the velocity, and all of these data are either scalar data or vector data. So they are all stored here in this empty object. Okay, before we proceed to create pardon me, before we proceed to create the data here in the DOP network, we should say that the operations in DOP network are just executed in order from up to down here and from left to right, and this is going to be more clear when we this is going to be clearer when we just modify our data and create our modified or our simple smoke solver. Okay, so here we have our empty object, and we need to create the fields that or the fields that represent our data that we are going to modify to create our simulation. To do this, we have a node called apply data here, which takes this object. Okay, so here we have objects to be processed. So here we have this gray line, which means that this is the object or the container line here. Okay, and we have this green line, which represents that data that we are going to create. So here we create data. Okay, so if we press tab here, we have fields to create. So fields. So here we have a lot of nodes here, but let's talk about two different fields, scalar field and a vector and a vector field. This is going, or these two are going to be our interest now. Okay, and actually they are the two main categories here. Okay, so we are going, for example, to create a scalar field, and here we have the output here, which we can connect here in this. Oh, I'm sorry, this node is not apply data. This is, I'm sorry, here this is the apply data, and here is our object, and here is our data here. So this is our scalar field. Okay, so here in this scalar field, we can scroll down here and rename it. Here we have the data name, so we can call it, for example, density. And here is the division size, which represents the size of voxels, or it's the same as voxel size that we have seen previously in the last video when we talked about volumes. So here we have the division size, which is a voxel size, and we have the center here, or the size of the field. In the previous video, I showed you that each volume has boundaries, or a bounding box, and this applies here to the fields. So here we have the bounding box of this scalar field of the density. So these are going to be the limits of our simulation. If we did any modifications to this or to the voxels inside this density field here, it's not going to go beyond these limits. So for example, I will create a 10 by 10 by 10 box that represents our field of simulation. And here in the voxel sampling, here we have center or faces or edge here. Okay, so our a field here is going to be composed of voxels, and a voxel sampling here says that where you want to put the data on this voxel. Do you want to put it in at the center of the voxel, or you want your data or your values to be at the faces or the edge or the corner of the voxels? Okay, so we are going to put the data on the center because this is what is accurate in simulations. You put the density on the center. Actually, this has a lot of math behind it, but we're not going to talk about this complicated math. So here we are going to put this at the center. We here have this border type here, and we are going to talk about boundary conditions when we talk about the gas enforced boundary. And here we have the initial value, and we can, for example, put a value to that is going to be assigned to all of the voxels of this simulation or of this field here, okay? And we are not going to do this now. And the slicing and these things we're not going to talk about now. The default operation, actually we're not going to talk about this now in this lesson. We may deal with this later, okay? So here we have the name, we are going to call it density, okay? But as we see here, let's like this. As we see here, if we put the display flag on this, we here see our density field, which is a scalar field, this data type, okay? And here we go. This is our density. We can give it maybe an initial value of 1, okay? What if we want to show or visualize this scalar field, as you here cannot see anything in the viewport? To do this, we are going to use a node called scalar field visualization. And we are going to put this node here. It's just attach it to the data here of this scalar field on this to this input here, okay? And here we can show the guide geometry, and we can use smoke. So here, if we just press G, here we have our field here. This is a box filled of voxels, and all of these voxels here have a value of 1. So here we have our density field, and we have this visualization here, which is this scalar field visualization. And actually here we can show or hide this. We can use smoke, we can show the bounding box, we can remap this smoke here and use different ramps, black body, and all of these things, infrared, and all of these stuff, and remap this based on the values. And here they are going to take the same color because they all have the value, all of these voxels have a value of 1. So this is very, very useful here, okay? After that, here we have all of the voxels have a value of 1, and we don't need this. Actually, we want to use, for example, a sphere or something like this to have to represent some voxels that have a value of 1, and I want all of the other values or other voxels to have a value of 0. So to do this, we are going to create our density field here or volume in SOPs, and we are going to import this into our DOP network. So to do this, I have here this geometry node, and here we can hide other objects, and we are going to create our sphere here. And this is our sphere here. We can, you know, make it 1 by 1 by 1, and we can use either Houdini VDB volumes or Houdini native volumes. So I'm going to use our native volumes because importing VDBs in DOP networks is not going to work. Actually, we will have to convert them into Houdini native volumes. So let's create a native volume from the start. So here we can increase the resolution here a bit, and maybe this is too high, I think. Yeah, something like 50, and here we can press D in the viewport and select this dark here. And here we can create a null and call this out density. Okay, so this is our density field here, and we can put this name here, density. So here we have our volume here, and here we have this sphere represented by voxels having a value of 1, and all of the outside spheres will have a value of 0. So here we have our density field. We should import this into the DOP network, but this is not applicable with this scalar field node. So we are going to delete this node and use another node called subscalar field, which can import the field from our sub level. So here in this node, we have this sub path, and we can choose this out density. Actually, it has the same things here, but we can here use sub dimensions in order to make our field the same as subs here, and then or we can use the size here to make it bigger if we want. So if we use the sub dimensions, it's going to use the boundaries of the volume here created in the subs, but if we want to resize this, we can do this ourselves. And here the division size, actually we can here, if we here go and select by size, it's going to be by voxel size or division size, and we can copy this parameter here and paste relative references in this because we want to link them. And here this size here, we can make it bigger in order to have space for our simulation. Then everything here is the same, and we can name it density field. Then here, after this, we can visualize this field, and voila, we have here our sphere here in the viewport. Okay, you can just turn off lighting in the viewport, and here we have our sphere and our density field here is in our spreadsheet. So now after we create the data here in our sub level in our DOP network, sorry, we can modify this data, and to do this we have this multiple solver node to which we connect the objects here or the data here. We have here this object with the data inside it, and we here connect it to this multi-solver node, and then we here have this purple data here or this purple lines here and this purple input where we can modify this data. So here we pass the object with the contained data, and this is what we talk about, what we have talked about, the order of operation in DOP networks. So here from left to right and from upside down, we here have firstly our empty object here, the first on the left, and it's the most here, the most up node here. Okay, so firstly, we had our empty object created, then to the right of it, we had this, down here we have this apply data, then to the right here, these nodes were performed, then these data were applied here, or were passed to this multi-solver node, and here, this node passes them to the right here to whatever nodes we are going to connect here to modify these data. So for example, we here have a node called gas advect field, and this node, for example, takes these density values here and advect them by velocity, which means they move these density values here according to the direction of a specific velocity that we can create. Okay, here you define the field that you want to move here, which is our density, and the velocity field here, which is this. We are going to call it vel, and voila, it should do this. But when you do, you are not going to have anything, of course, because you don't have the velocity field. So we are going to create this velocity field, which is going to be interesting. So we are going to create a geometry node here, geometry node here. We're going to create our velocity field here, and inside it, I can create a box, for example. Oh my God, what's happening? A box, for example, and this box here is going to be something like 30 by 20 by 30, something big like this. And we are going to add a node called points from volume, which is going to here, this node, and it scatters node here, then on and inside this box we are going to, oh my God, the separation is too high, so I'm going to put the point separation here to point. Oh my God, this is not working. I don't know why, but something like this, and we have our points here. In the next video, we are going to continue creating our velocity field, and then we are going to advect our density and see what happens in order to have a complete picture of the order of operation in DOP networks, and how these nodes here, get the gas nodes or the microsolvers nodes and the different nodes, can modify our data that we apply to our object. So we're not going to make this lesson longer than this. Thank you for watching, and I will wait you in the next video.